What's up, U crew? This is Dustin with Electrician U. So this is part 2 of my service rebuild. If you didn't catch the first video, click up here, this little card, it'll take you to the video. It's essentially me demoing my existing service, building a new service with Square D gear. So I got, the weatherhead put up, I got the panel, got the meter put in and wired. And then this video is going to be from there to the end, the last finishing touches, putting the breakers in, landing everything. So enjoy. Alright, so now we've got all of our incoming service conductors landed. We've torqued everything to manufacturer's specs. That's really important to do. Now it's time to start working on the actual conductors that are getting tied into the breakers. So what I like to do first is I like to land all of my neutrals and kind of get them out of the way. Normally what I'll do in most panels is I will land all my grounds, my equipment grounding conductors first, and just get all of them, out of the way. It's the thing that's behind everything. And then I'll go and do all of my neutrals or my grounded conductors. And then the last thing that I do is my hots or my ungrounded conductors, because it just kind of stacks everything in layers behind, in the middle, and in front. But in this situation, I'm not doing that because this panel is a little bit different. All my wires are too short as it is. So I'm trying to address that. So I'm actually leaving the grounds to be the last thing because I'm trying to make sure that I have enough length on my neutrals and my ungrounded conductors before I mess with any of my grounds, because then if I have to adjust or move anything around, at least I know where I need to put things, because the grounds and the neutrals were really the shortest things in these panels. So the neutral, it was pretty crucial for me to make sure that the neutrals landed where they could. The grounds didn't really matter as much, and the hots I actually had length on, so I didn't have to really worry about that for all of my hots. One method that you could do is you could add wire nuts to every single one of these neutrals that's too short and extend them with more wire and land them on the neutral bus. But for what I had here, that would just be like this huge ball of wire nuts that would be stuffed in there, and I just didn't like how that looked. Now that we're in the service panel and all of our grounds and our neutrals are already bonded in this panel, I put an extra bus and attached it to the back of the panel. I didn't have a floating isolated neutral bus because, again, we're already bonded in this panel. We don't need to have that isolation. If this were a sub panel somewhere, you would have to do an isolated ground or an isolated neutral bus that has some plastic behind it, so it's not bonded to the panel. But I just put another ground bus in. I attached all my neutrals to that, and then I put a bonding jumper from that ground bus up to my neutral bus. And that gives me a conductor dependent bond. And I do the same thing on my grounds. At the very end, I put all of my grounds in. I put a bus down at the bottom because that's the best place for all of them to reach. But rather than relying on the enclosure itself to be the fault current path if there's a ground fault, I wanted to actually run a conductor from there up to the bus, so it's conductor dependent. So if there's a ground fault or a short circuit, either way, I've got a conductor that goes up to the buses, and it has a much easier time, I think personally just a better method of making sure that we can clear a fault in that situation, rather than going through one screw on a bus that's being held in, maybe kind of loosely, maybe tight, who knows, but then having to go through the enclosure, the metal of the enclosure itself, to try to find its way back to neutral. So that's just my opinion, though. There's methods out there. It's okay to do. A lot of jurisdictions are going to have different rules on what they want you to do, so you don't have to do it this way. This is just what I'm choosing to do. And here's a code reference if you want to read a little bit more about this. If you are curious to know more about bonding jumpers, there's a whole lot to know. Now that I've got all the neutrals landed and I know that all of them will reach, it's time to start hooking up all the breakers. So I'm hooking up 2 pull 20 breakers because I've got 12 3-home runs pretty much run throughout the entire house, so that it's basically a black and a red phase conductor, a black and a red hot. two different home runs are sharing a neutral. That's what they call a multi-wire branch circuit. So they don't make, if you were to take standard arc fault breakers or dual function breakers and try to put them in just single pole breakers with sharing a neutral, you wouldn't be able to wire it correctly. And if you tried somehow sharing a neutral and like pigtailing two neutrals out from one neutral, you'd have nuisance tripping. You'd have nonstop tripping all the time. They're not designed for that. So they actually make a 2-pole 20 arc fault shared neutral breaker. And it's something that I'm going to install. I have not installed it yet, and I don't have any of them. So for the sake of this video, I'm not putting them in. There's going to be a video coming up where I actually talk very in-depth about arc fault dual function GFI breakers. So I'm going to install those then, and we'll talk about that a little bit more and why that's important later. But for the time being, I just want to make sure that I have common handle ties for both of the circuits. So both my black and my red for my A and B phase conductors have a shared means of tripping because they're sharing a neutral. So if there's a problem with one of the circuits, it's going to trip both of those circuits. And that's very, very important to do. One thing that's really important to do is make sure that you get the bonding jumper screwed in. A bonding jumper can be a conductor, it can be a screw, it can be a couple of different things, but what a bonding jumper is doing is it is bonding the neutrals and the grounds and the enclosure together. So in all of these Square D panels, Square D actually includes this green screw that comes in the neutral bus already, and you have to hammer it and hit it hard so that it'll penetrate and get into the enclosure on the back side. And then you have to turn it several times for, to screw it down to make sure that it has a solid bond. That's a really, really big thing to do. You do not do that on any sub panels. You only do it at the service panel. So if this were a panel in the garage, I would not do this. I would take that green screw out, throw it away. Well, I probably would keep it just in case I lost one for like another job, since I pretty much just exclusively use Square D. But you only do this at the service. So coming out of the meter, first service disconnecting means, panel, main disconnect, whatever it is, that's where you make this bond. So it's really important to get that green screw in. Now I need to put the little rubber guards on. This is kind of a new addition relatively in the last few years with Square D, where you have these little rubber guards that you put over the main lugs, just as an additional layer of protection for anybody putting hands in live panels. The only thing that I don't have is an intersystem bonding bridge, but my inspector is not going to really worry about that. That's something that I will add in another video. It's just not something that I have right now. And another thing that I'm going to do is I'm going to add a supplementary ground rod in the future. The ground that I have right now was smaller. That's a slab ground, but it's smaller than it should be because the panel was really small. So now that I'm upgrading to a higher size, I need to actually add a little bit of meat to my equipment grounding situation. So I'm probably going to take one or two ground rods, probably two ground rods, up the size of the grounding electrode conductor and put a new grounding electrode in there just to make sure that I've got some supplementary protection, knowing that this is a really old system that was sized for 125 amp service. So the last thing I had to do was call my inspector, schedule an inspection so that he could come out, make sure everything was good to go. He did. He passed the inspection, so then I had to call the power company out and get the power company before they closed for the day. They would still do like emergency after hours stuff. I would just have to pay a little bit higher fee, but they would still come out, just trying to not have to pay those fees. So I made sure that I got a green tag on my inspection, and also got my power turned back on same day. So that was a little bit of an arduous thing, having to try to do it all that way. By the time the power company came out and disconnected and I started filming, I already had, I was recording. So I had my GoPro on my chest, and I had the camera that you're watching me with right now sitting out there. And I had another camera that I was going in and trying to take footage. Just the fact that I was trying to film all of this and do it all within like a 4-hour window was stressful as hell. Usually when you replace a service, you kind of give yourself a time allotment of a full day, like a good 8-hour day. That way you can take your time. You don't have to be just like balls to walls going crazy as fast as you can. I was going balls to walls crazy as fast as I can. I could have done much prettier work and much neater work. There's probably 20 different ways that I could have done a lot of different things. And had I had the time to make a trip to Home Depot or a supply house or whatever to like get every single possible thing that I could have done a much better job at this looking outstanding and making sure every single thing was thought of. But I did what I needed to pass my inspection to get everything in for me to feel safe as the homeowner and as the electrician doing the work. But I hope you got something out of it. I hope that you maybe learned a thing or two, or if you have opinions on things you think I should have done, I'm sure you're already writing them. I know. There's a dozen ways to skin a cat. There's some things people are probably going to be like, why didn't you do that? Why did you do that? You should have done this. You should have done that. My house is standing. I'm sitting here. Everything's fine. It's okay, my dude. When you build your service out there, go and do all of those pretty things that you're talking about. So, you crazy people, let me know what you guys think. Thank you guys so much for your support, and I will see you in the next video.